So I think we've all had the suspecting feeling that our food has become less healthy over time. It turns out that's true. How do we know that food has become less healthy? Well, one, I made this graph. When you select between 2 years, you can kind of see 1950 just ends up having healthier amounts of food. This is for 100 grams of broccoli. Now, I got the data to make the graph from this research paper. So, what Donald R. Davis did in this paper, and he describes it, I'm not reading all that shit. He took different foods, and you can see them here from cabbage, asparagus, cauliflower, and he just recorded, the amount of proteins, carbs that was mentioned in the USDA food database. If you don't know, the USDA has this food data database. It just has recorded data on how many calories that food item might have, how much water. Here's a closer look at the data. All the food items have a number. And so 7 relates to cabbage, 1 relates to asparagus. From here, you have the amount of, X variable in 99 and in 1950, how many samples were used to, determine that outcome, and also just the standard error for those calculations. I just put that in my own spreadsheet. This spreadsheet's kind of messy, but I think spreadsheets are a good way to keep your data organized. And so you can see I also calculated a rough estimate of my daily recommended value for each nutrient. You might be wondering why I chose daily recommended value as opposed to raw amounts. And that's because nutrients vary wildly in mass. So, like half of these, more than half, are micronutrients, and those are really recorded in milligrams, while water, protein, those are measured in grams, and so 1,000 times. To solve that, I came up with a way to record the daily recommended value of all this, and it's kind of in percentages. And so for cauliflower, 100 grams in 1999, that's about 7% of my carbs. And you can kind of see the formula here, which is taking the amount in just grams and dividing it by an estimated amount of 25% of the daily recommended stuff. Now I have the data, presumably in a nice readable format ish. How do I get from this data to like this nice interactive? This is cool. This is sick. I coded it. There's a programming language called D3. Really cool for this. So I'm gonna try to go over the code really quickly. I actually believe in coding in vanilla JavaScript and HTML5. Sue me. So this code might be a little messy. You have the code for sale down below if you do want to check the code more seriously. So basically, we have this information, which is the raw data. This data is received from this research paper. With that information, I have a breakdown percentage. These are the nutrients, and these are the amount of daily recommended value that they meet. I start with taking this initialize SVG function. And what that does is take, whatever div I designate as my SVG container, do some D3 stuff to define the width and the height. At the end of my initialize SVG function, I do call create radial chart. And this is where a lot of the magic happens. Now, in create radial chart, what I do, because I did initialize the SVG already, is take that SVG and also take the data. I then define the X and define the Y variables, and these are essentially defining how everything is spread out on the chart. If you don't know what D3 does, it basically links data to elements like paths and rectangles, and it basically sets the variables, the height, the width, the location of those shapes using the data that you linked it. And I'm just setting the variables based on the data. So that includes the name of the nutrient. These are the things that define like the start and end angle of the arc, how big and tall that arc is. I also create these reference circles, and those sit on top of the data, so are drawn second. And that just allows people to understand what's going on. You need some kind of key when making a graph. The key is defined with the reference values and reference circles. I'm drawing the reference circles after the bars and the arcs. And then I'm also setting some specific rules for the trickier words. I don't know why I added the transition, they're not moving, but you have now an understanding of like what the 20% is, the 40% is, and 80% is, which, ends up being 10% and 5%. How do I handle the changes in the graph? Now, that's a little messy. So basically, a bunch of function calls. Interactions might include check marks. They might include button changes. They might include a drop down. These are all ways that the computer can interact with humans, and all of these have something called an event attached to them. So basically, each of these different selectors just have their own function call. Luckily, HTML elements now have this on change attribute. For some elements like buttons, it's on click, but the main thing is to focus on events. All these HTML elements have values. These values are a way for me and the code to understand what was clicked. If it was a drop down, each drop down has a value. If it was a check mark, each check mark has a value. Each button doesn't have a value, but they have a specific function call set with, a value as a parameter. I won't go through all the different functions because it's kind of repetitive, but it all culminates in this update charts function. First, we just check all of the checkboxes that are selected. Um, and then we filter out each of the data sets you saw earlier to only include the checkboxes you saw. There, we read the name of the food that is from the dropdown, and we also read the specific year that is fed in from the buttons, and we just call the create radial chart function with that specific data set. Again, probably a neater way to write this. Now, what the data did show was that not all nutrients were decreased equally. Some things like water kind of stayed the same, while things like thiamine apparently and niacin definitely decreased. There are a couple of hypotheses as to why this happens, but a big part of it is also this idea of the green revolution. Basically, after World War II, we had a lot more chemicals left over that weren't doing shit, so we decided to invest in pesticides and fertilizers. If you want a more full in-depth breakdown, I do have a blog post in the description that talks a little more about my process. If you do want to take a look into the weeds for yourself. I guess the point of this video is just to show a little bit about my process, but also to kind of show definitive proof that our food is becoming less healthier. Technically, this is just the data, so whatever. If you like this video, please subscribe or whatever. You know the vibes.